Section 5.2 Trigonometric functions for real numbers. Recall that from section 5.1 we learned that for any real number t there is a terminal point xy on the unit circle. What is a unit circle? Again, from section 5.1 the definition is repeated here, that the unit circle is the circle of radius 1 centered at the origin in the xy plane. The equation of the circle is x square plus y square is equal to 1. Now, if a circle with unit radius is drawn anywhere in the plane, it is not a unit circle. For it to be a unit circle, its center must be on the origin. So if you move this and put it on top of the circle which I have red, then it becomes a unit circle. Now we will define the trigonometric functions in terms of the terminal point related to the real number t. So the terminal point could be anywhere on the circle, unit circle. It could be in the first quadrant, it could be in the second quadrant, it could be on the third quadrant or the fourth quadrant, or it could be on one of the points where the axes are intersecting with the unit circle. So in here we will talk about the special points that we learned in section 5.1. Points with the t values for which the terminal points can be found on the unit circle. Okay. First we define the functions, the trig function. There are 6 of them and their names are given here in the first row and their abbreviations are given in the second row, and these abbreviations are the ones that we use to write the functions, but when we say them, we call them by their name. So the names of the functions are sine, cosine, tangent, cosecant, secant, and cotangent. And the abbreviations are given below. Basically, the abbreviations are the first 3 letters of the name of the function, except for the cosecant function, because if we use the first 3 letters, it is COS, which is already taken. So we have a different symbol for the or abbreviation for the cosecant function. So they are defined like this, that the sine of t, we read it like this, we write like this sin and then space and t. Sometimes we can put the t in the parentheses. Sine of t is the same thing. We say that it will be equal to the y. So what is the y? Y is the y coordinate of the terminal point. So x, y here is the terminal point of t. Then the sine of t will be equal to the y coordinate of the terminal point. Cosine of t will be x. So cosine of t will be equal to the x coordinate of the terminal point. Tangent of t will be equal to y over x when x is not equal to 0. If x is 0, we will say that tangent is undefined. Now, cosecant of t is equal to 1 over y. Y should not be equal to 0. If y is 0, we say cosecant is undefined. secant of t will be equal to 1 over x. Again, x should not be 0. If it is 0, we say it is undefined. Cotangent of t will be equal to x over y, and y is not equal to 0. So if you know the terminal point for a real number t, then you should be able to write the sign all these 6 trigonometric functions. So here are some of those points, some of those t values that you noticed in section 5.1, and if you can recall the corresponding points corresponding to these t values from section 1, you have to kind of memorize those terminal points for each of these values, so you can easily write the trigonometric functions. So here we will try to write only 3 trigonometric functions: the sine, cosine, and the tangent. Because once we know these, we will have some identities later on by which we can find the other 3 trigonometric functions. Now let me do a couple of these, fill in a couple of these blanks, and the rest I will leave them for you to do. So for the point t is equal to 0, so this is t in the first row, the t value. So the 0, when t is 0, where is the point? The point will be right here on the where the positive x-axis crosses the circle. What are the coordinates here? 1, 0. So the coordinates for 0 are 1, 0. So that sine of t or sine of 0, we read it like sine of 0 will be 0, because sine of 0 is equal to y coordinate. Cosine of 0 will be 1. Tangent of 0 is y over x, so 0 over 1, which is 0. Okay. So let me do one more. Let me do this one, 3 pi over 2. So where is 3 pi over 2? Again from section 1, if you recall. So from the point 1 until this is t is equal to 0, and if we go up till here is pi over 2, 2 pi over 2, and then we come over here, this is the 3 pi over 2. So this whole length from the 0, t is equal to 0 to up till here, this is 3 pi over 2. And what is the coordinates? 0, negative 1. So when we write the split functions, sine of 3 pi over 2 will be equal to the y coordinate of the terminal point, which is negative 1. Cosine 3 pi over 2 will be 0. Now tangent of 3 pi over 2, that will be y over x. X is 0 and y is negative 1. So we have negative 1 over 0, which means undefined. So this is how you fill the rest of them. So I will leave it for you guys to do it, and then I will come back and meet you in the next video.